Welcome students to your favorite channel Pradeep Sir Classes has PSC, and today we are IIT Foundation course. It is about ICSE as well as CBSE, and today we are discussing about ICSE-10. So the topic is center of gravity of some regular shape as well as irregular shape. So the main topic is center of gravity, or in short form we can write as CG. Okay, so it is all about CG. What is CG? Not center of mass, it is another chapter. So in this chapter we have to know what is about weight, what is about moments, and all the concepts are related with CG, center of gravity. So this is ICSE-10, and this is center of gravity of some regular as well as irregular shape. So students, let's start the lecture. So students, first of all, before starting my lectures, you have to note down the definition, or the question is what is CG, or what is center of gravity. But define, or we can write as define CG. Define. The question is define center of gravity. Or simply an abbreviated form, it is CG. Define. Well, first of all, students, you have to know what is CG, or what is the definition of it. So you can write as you write, I think. So CG is the specific point. If we consider an irregular shape of a body and it consists of large number of particle, it is constituting particle. So it is suppose M1, and the weight of these is W1, and the weight of this one is W2, and this is W3, and this is W4, and this is W. Suppose N, it is N. Why it is N? And it is CG. CG is that specific point. So this body, if we consider a body of irregular shape, and we can take anything. We can take this tomato. This tomato, it is an irregular shape. It's not a sphere, not like cylindrical structure, or not like a rod shape. So it is an irregular shape. So it consists of large number of particles, and if you consider all the seeds are the particles, so everything within this mass are particles. It consists of large number of particles, and the weight of the particle is W1, W2, W3, W3, ... and up to Wn. And what is the gravity or gravitational pull? That is, gravity acts on the constituting particle, and earth attract all the particle, that is the constituent of the body. So is all the forces are parallel or not? Suppose there is the earth, student, there is the earth, and if there is a point object, then this is the center of earth, and this point, if the mass of this point is m, then earth attract that particular mass along this direction with a force, and this we know that this is mg, where g is approximate or average value is 9.8 meter per second square in SI system. Okay, so g is the acceleration due to gravity, and if we multiply it with mass, then we can get weight. So weight equal to mg, and this weight acts. Why? Weight is a vector quantity, so it has a specific direction and is always act along the center of the earth. So mg is a weight, and it acts along the center of Earth. This is the point object, and Earth consider this object as point object. But if you consider, is this is the point object? If I am the point object, if this mobile, if this board is the point object, then the answer is no. This is not a point object. If you consider, student, this is a chalk, and if we consider this particle, the particle of the chalk or dust of the chalk is the point object with respect to this one, then we can consider me or this chalk as a point object with respect to Earth. Okay, so this is a concept when we consider a particular body is as point object. If you go to America, then American said from where you come, then you can say that I am an Indian. So India is a point object with respect to the another abroad. But if you are in India, if someone said that where you come from, then you have to say I am from West Bengal. And if you are in West Bengal, then you have to say I am from Durgapur. And if you are in Durgapur, then you have to say I am from a zone. Okay, so with respect to the different object, you can consider this is as point object. So this particle is considered, Earth considered this particle as point object, as I think that these dust particles are the point-like structure with respect to this chalk one. So this is an extended object, but Earth considered this object as point object. So this is the Earth, and Earth considered all the constituting particles. Suppose if this is Earth and these are the constituting particles, then these force are not parallel. Is these forces are parallel or not? No, because parallel lines are always drawn like that. So why these are parallel then? Then the question is that this is like that. So all the forces are not parallel. But since Earth considered this one as a point object, then we can say that this all forces are act in parallel direction. Is it clear or not? Earth considered this object. Earth is an extended object, and Earth considered this object or this chalk as point, and it attracts along this direction. So if it is constituted of different particles, then all the particles act like this one, and all the forces are parallel. So parallel. So what is about? We are talking about a center of gravity. So it is a body, and the center of gravity lie at that point. Why? Because the moments of all the forces, if this is a fulcrum, the Wn and W4 and all the constituting particle along this direction act along, try to rotate that particular body with this direction, that is in clockwise direction. But all the constituting body, these and this one, try to rotate this body along this direction. So this is clockwise and this is anti-clockwise. If these two moments are equal, suppose if we consider a chalk, and try to balance this one at that particular point, yes, it is balanced. So all the constituting particle from these and try to rotate the chalk along this direction, and these constituting particle along clockwise direction. And if the clockwise moment and this is clockwise and this is anti-clockwise, and if this clockwise moment is equal to the anti-clockwise moment, then we can say that this chalk is in equilibrium. So the center of gravity lie at that point. Where is the center of gravity lie for a rod? This is regular shape. So this is the axis and center of the rod, along the axis and at the middle point of the rod. Okay, so it is along the axis and at the midpoint. So define center of gravity. So center of gravity is the specific point about which, if we take a moment, there is force into perpendicular distance. This is force into perpendicular distance. This force into perpendicular distance. This force into perpendicular. And take algebraic sum. But you have to consider the sign convention. So what is the algebraic sum? 4 minus 3, that is 1. So plus 4 and minus 3 results 1. Similarly, if we take this one clockwise direction as negative and anti-clockwise direction as positive, then you have to take algebraic sum of all the moments. So the algebraic sum, so center of gravity is that specific point about which, if we take the algebraic sum of all the clockwise and anti-clockwise moments of the particles are 0, that is the body is in rotational equilibrium. What is about rotational equilibrium? We are study about the two equilibrium in that particular chapter. That is, you have to, if you were first in that particular class, then go back to the previous one and enjoy the concepts given that is related with what is moment, what is the convention of moment, what is the principle of moments, and then what is dynamical equilibrium, what is static equilibrium. And today we are discussing about center of gravity, and the related topic is at that moment is rotational equilibrium. When that particular body can't rotate, when the clockwise and anti-clockwise moments are equal, then we can say that this body is in rotational equilibrium. So center of gravity is the specific point about which we can take the algebraic sum of all the moments is 0. Then this specific point is called center of gravity. Weights of the moments about this point. So you have to mention that terms. Weights of the moments about this point is 0. That is, the clockwise moment is equal to the anti-clockwise moment. Then this body is in rotational equilibrium. So the body cannot rotate along this direction or along this direction. Then we can say that this is the CG. So I think you have understand that particular concept, what is CG, center of gravity, and you have to write what is a defined center of gravity, and then definition, and then you have to read what is about the center of gravity of the regular shape. And students, you can write that particular table. Okay, you can write that particular table and read one by one. Okay, so I discussed one by one. So what is the center of gravity of the rod? And the answer is along the axis and the midpoint. So if we consider this is a rod, then center of gravity lie along the center, along the axis and at that point. This is the CG. And if we take a circular disc, so this is then at the center of gravity lie. And if we want to balance this circular disc, then we have to like a chakra. This is, you have to, here is the point. And then we have read that great mythology that is related with the chakra, Vishnu and Vishnu's chakra. So this is the actual point of center of gravity. A center, solid or hollow sphere. So if it is solid and if it is hollow sphere, then at the center for both the cases, the CG lie on the center of that point. Okay, so this is also center, and this is the center of the hollow. It is hollow and it is solid. So if it is hollow or solid, for both the cases the center of gravity lie at the center. For that particular concept, there is another question you have to write. Is center of gravity lie outside the material? Is CG lie, CG lie outside the material body, is CG lie outside the material body, then the answer is yes. This lie on the outside of the material body. If it is a hollow sphere, then the center of gravity lie outside the material. That is, it doesn't lie on the surface. Center of gravity is outside. If it is a ring, then also if we take a ring, then also center of gravity lie at the center of the ring. Okay. So this question, you can write this question and the answer is yes, center of gravity lie outside the material of a body, and it is for a circular ring or a hollow sphere, the center of gravity is the center. And then the solid and hollow sphere. So the next one is solid cone. What is about cone, students? What is about cone? And where the center of gravity lie for that particular cone? If we consider this is a cone, then if it is a solid, student, don't go for the derivations of the calculations of center of gravity, just remind that particular one, and if you are in class 11, then you can easily calculate it. What is the calculations related with? For that class, you have to just remind that particular one. If it is solid, then if we take this one or divided this one as 4, this 1, 2, 3, 4. If we cut that particular height with 4, then the center of gravity lie at that point. So it is, if this is the total height, then we can say that the center of gravity lie at h by 4. And if it is a hollow one, then the center of gravity, if we cut this as 3, then the center of gravity lie at that point, and this is h by 3. This is h by 3. So since this is height of the cone. So this is the case of solid and the hollow one. Okay, since hollow cone, it is h by 3, and if it is solid, then it is h by 4. So this is cone like structure. And the next one is solid cone as well as hollow cone. Then circular ring, students, you have to know that one. Circular ring, if it is circular ring, then the center of gravity lie at the center of the ring. And what is about triangular lamina? Triangular lamina means triangle. If it is a scalene triangle, it may be. Then what is about median? It is the midpoint of the side. And if we consider, if we join this median with the vertices, then if we connect all the median, then there is a point, intersecting point, and this is the center of gravity. So it is the intersection of all the medians. You have to write the intersection of the median is the center of gravity. So this is a triangular lamina. If it is a scalene or equilateral triangle, it may be you have to join all the medians just and get the answer. So the next one is parallelogram. So if it is a rectangle or a parallelogram, it may be the different shape. You have to join just the diagonal of the parallelogram. Okay, so this is the intersection point of the diagonals. So intersection of the diagonals gives a center of gravity, and if it is a square, then also center of gravity lie along the cross section of the diagonal. If it is a rhombus, then also you can get the diagonal and get that particular point. That is, it is the intersection of the diagonals. Okay. So these all are the regular shape. First of all, students, you have to know what is center of gravity, then go through the different shape of the concepts. Okay. And then what is the center of gravity lie for a irregular shape? Suppose a block, and this is the shape of the block, and where is the center of gravity lie for that particular one? It is a regular shape, it is a regular one, but this is not a regular shape, and you have to calculate this one and where the center of gravity lie. Then what's the answer? Then the answer is there is a practical method. Okay, so a practical method, there is a practical method. There is a practical method. Practical method. So there is a practical method for calculating the center of gravity for an irregular shape. So students, think this is an irregular shape, and you have to just suspend it with a pin so that it can freely swing over a particular plane. Over a particular plane. It can swing over a particular plane. Suppose if this is the irregular shape, then you have to join like that one, and you can suspend it over it. And then you have to join a plumb line. Okay, what is about plumb line? You know that. And just you can also join a heavier material, that it may be a nut bolt with a spring, it may be thread. If you can put a thread along this point of suspension, this is point of suspension. Point of suspension. Point of suspension. So at the point of suspension, you have to swing a thread with, this is called plumb line. This is called plumb line. This is called plumb line. Okay. So there is a line, and similarly you can suspend it at that particular point, then you also get a particular point along this line. And if you suspend it here, then you can get another point. And like that you have to suspend it 3 times or more times. You can want to suspend it for greater accuracy. So there is a intersecting point of all the plumb lines, and then you can get, and you can say that this is the center of gravity. So this is the center of gravity. So this is the practical method for calculating center of gravity of an irregular shape, of an irregular one. Irregular body. And students, I think you realize all the topics, and I revise this one. That is, what is center of gravity? First of all, the 1 number question is what is center of gravity, and the second one is what are the different shapes, and what is the center of gravity for the irregular ones, and this will be that particular one. And the second one is how you can calculate the center of gravity of a irregular shape. Okay, so that is all about center of gravity, and I think you realize very much. And if you don't, then you realize that this is the most conceptual channel, and wow, what a concept, then you can subscribe and wait. Last of all, say that continue your study. Thank you.